Now, today's webinar is about time-based versus event-based motion. Um, it's a very particular topic in a wide world of animation and motion that we could really talk about. Uh, in order to really get into some of these things, I felt that we had to go back and take a look at the basics of the motion products that are included and clarify what's actually there. Before we get doing that, I'd like to just launch a couple polls here, just to gauge where everybody's minds are at this point. The first one has to do with SolidWorks Animator. SolidWorks Animator is included in what package? Go ahead and vote, and then I will actually launch the results here. Okay, we got about 53% voted here. I'm going to wait for the rest. Okay, that's good enough for me. Let's go ahead and share the results. This is something that you may not know at this point, but SolidWorks Animator is no longer a product. SolidWorks Animator is included in the base package, essentially, of SolidWorks now, and it's not even called Animator at this point. It's called Motion Studies using a motion manager. They've actually integrated several different things into this motion manager. So in reality, you can't buy it as an add-in, and you can't get it as part of Premium or Professional as an extra option. It's there in every core seat. Now, some of the functionality is limited in those as well. One more poll that I have here, just to get a sense of what everyone is kind of here for. We have a broad cross-section of companies that are on this webinar. I want to get an idea of the types of things you're looking to do. Okay, 40% voted. Okay, I'm going to go ahead and close the poll and share the results. It looks like we have a pretty good cross-section, as I expected. A good cross-section of what people are looking for today. My job in this webinar is to clarify what those 4 items are. What is the difference between an animation, basic motion, time-based, and event-based motion, so that you can accurately make a choice as to what you're trying to do on a day-to-day basis. So let's start out with our PowerPoint here. Taking a look, what we're going to cover today is essentially what's available to you, what the different packages are, and what the difference between them. Each section that we go over, I'm also going to do a little presentation, a little demonstration of each of the different portions, and then we'll open it up for Q&A at the end. It's pretty clear to see how in the SolidWorks arena of the four-pronged approach, where these things fit in. Some of them are part of simulation, some of them are part of design, some of them can even be translated over into publishing, creating animations for publishing. So you can see it fits very nicely, some of these topics in the SolidWorks world. Now, SolidWorks calls the old animator product Motion Studies or Motion Manager. This is anytime you want to create a graphical movement or simulation for assembly models. The Motion Manager, which exists inside of SolidWorks, is timeline-based interface. So the interface looks like a timeline, however, but it includes the following motion study tools. Now, animation, which is not called Animator, the animation is what you can get out of it, is available in core SolidWorks. There is the next step up, which is basic motion, which is also available in core SolidWorks, and I'm going to go through each of these individually. Beyond that, you have a third option in the Motion Manager called Motion Analysis. You're only going to get that option if you have SolidWorks Motion That's an add-in in SolidWorks Premium. These are 3 sub-selections within the Motion Manager, 2 of which you have out of core SolidWorks, 1 is required for an add-in. Now I wanted to bring this up because we're going to get into the Motion Manager considerably. I cannot in any way expect you to, or expect me to teach you motion in an hour lunch and learn. There are a lot of different symbols that mean a lot of different things, and there's a lot of tips and tricks to creating all these different pieces. We may refer back to this image to say, hey, you know, this is what it's doing here, this is what it's telling me. But here's just out of the help menu, you know, some of the icons that you'll see within the Motion Manager as we get into it. The first part of the Motion Manager options that we have available to us is animation. Animation is the ability to drive motors of 1 or more parts. We can prescribe positional changes using what we call key points. Key points keep a location or a moment in time ready for reuse. Animation also uses interpolation to define the motion between the key points. So it tries to figure out what happens between those key points. I want to take you to SolidWorks and show you a little bit of motion. Some of these you may remember from the past What's New seminars along the way. You'll notice down to the bottom left-hand corner, next to my Model tab, I'll have a tab for Animation. This is where I go ahead and access my Motion Manager. My Motion Manager is this entire interface that we're dealing with here. Now the Motion Manager is automatically going to extract out a lot of the standard items that we see in our Feature Manager. Things like camera views, lights, mates, and patterns, those types of things. You'll also notice there's several commands along the top-hand portion of this as well. Now, I happen to be in a camera view in SolidWorks. We're all familiar with creating cameras and setting camera views. So I'm actually in a camera view in this case. I'm going to show you how we might create an animation of different things. Now, animation can be something as simple as flying around an assembly. It could be changing lights. It can be turning transparency on and off, changing colors. It can be, you know, shutting files on and off, making them completely transparent. So there's several different things that will allow us to create an animation. Now, one of the key components to that is this option here, this green diamond with the lightning bolt to it. It's called Auto Key. What this is going to do is, as you move your timeline, it's going to capture the changes that you make to the model. So in this case, what I want to do is I want to animate my lights. Now if I expand my lights folder down here, if I right click on my spotlight, I can physically show my light now. And you can see what I'm dealing with. I have a light coming in from the right hand side. Now what I want to do, if I drag my slider bar out, let's say to 2 seconds here, I can then at this 2 second, because of the auto key option on, I can then make a change to the spotlight. Now very simply, just like changing a spotlight, you can change it in the feature tree or in the Motion Manager tree as well. What I want to do, and I want to change the color of it. Maybe I'm going to make it yellow. And I'm going to change the position of it. And this is just changing the longitudinal value. Okay, and I'll go ahead and accept that. By accepting that command, the system automatically creates the keys that I need to change that spotlight at that point in time. Now if I drag off to maybe 4 seconds, I can then do the same thing. Go to my spotlight. Maybe I want to change the color to blue. We'll go with dark blue here. And then maybe I want to change the position to a different angle. Okay. Now very simple start to this here. Let's go ahead and turn off my lights for a moment. Now I want to change the camera position. I want to start to zoom in and out of this model. Again, because the auto key is on, it's going to capture it for me. But if I look, there's one other place that we have to go to make sure that our camera views are locked or unlocked here. Let's see. Now, when I edit the camera itself, there's an option in here to lock the camera position except when editing. Now, if the camera position is locked, it's not going to capture the changes in your view. So since it's unlocked in this case, I now can say, you know what, let's drag my time bar out to maybe 5 seconds, and I want to zoom in. Ooh, let me get to where I want to be. I want to zoom to this location. And then maybe I drag it to 6 seconds, and I'm going to start to slide along this edge. Drag it to 7 seconds. We'll get maybe all the way down to the end here. And let's finish it off with 8 seconds, and we'll actually rotate the model to a top view so I'm looking down in. Now all I've done is let the system, notice the blue keys, the system has automatically grabbed that information based upon my camera and captured it because of this auto key. Now I can take my little time bar and actually go back and slide it back to see what's happened, or I can physically come up here and just hit the play function. Notice the color changes, yellow to blue. It's zooming in, bringing along the edge, and going up to my last position. Now, I'll apologize ahead of time because I'm not sure how these animations are going to show up across the webinar. I'm hoping they're giving it some justice here. The other nice thing is, and I just want to point this out as it relates to animation here, at any point in time, because of the auto key, let's say at this point in time I wanted to make the ground disappear. I drag my time bar to that point and I set it to hide. Maybe I want to go down a little bit further to 6 seconds and I want to set it to show. Okay, now these are all captured very easily by the system. You can see I come in here, boom, hides, shows, happened kind of quick there, but very easy to capture that information. So that's basic animation or animation in the Motion Manager. Let's go back and look at what other options we have available to us. The next step up is basic motion. It actually is a different selection within the Motion Manager. Basic motion allows us to get some physics involved. We can start to bring in motors, springs, contact, gravity. It does take into account mass in calculating the motion. They've done this and actually sped it up to make some really relatively fast what they call presentation-worthy animations. I'm going to show you an example from the past of basic motion problem that we have here. So let's go ahead and open that up. Most of you have seen this in the What's New examples several years ago. We have a series of different size, we'll call them marbles, and as gravity brings them down this slider, they will fall through the gap in the slider to the proper tray based upon their size. Now, if I go to my motion study here, Motion Study 1 is the name, and again, these can be renamed to call it Ball Study or whatever you want to call them in this case. You'll notice I'm still set at animation. But watch what happens when I decide I want to start to add some of the other things like gravity and motors and like that. If I grab gravity in this case, you'll see that the tool says you are required to use basic motion or motion analysis in order to specify gravity in this case. So I have to make my selection for basic motion. Now keep in mind the third selection, motion analysis, will only be available if you have motion, which is part of premium or beyond the simulation packages. Okay, so if I select my basic motion, I can determine which direction I want gravity to be. I want to go the negative y direction. Now I need to make sure that all of these components interact with each other, and we do that through contacts. If I select contact, in this case it's kind of a random contact. I'm really not sure how they're going to fall. I don't know whether this ball is going to hit this one over here. I really don't have a good idea of what's going to happen. So what I can do in this case, this one's very simple, is I'm going to go ahead and add a contact between all of the components in the model. You'll notice off to the left in the contact manager, you'll see that it's created 105 pairs of contact. 105 pairs. Now also at this point, this top line in the motion manager tells you the duration of the motion study that you're creating under basic motion. I can actually drag this out further because I'm not really sure how long it's going to take these balls to fall in there. Okay, so once we have all that, there is a little bit of difference when it comes from animation to motion in that we actually have to calculate the physics of the problem. So next to my basic motion pull down, you'll see a calculate option. And if I select calculate, the system's going to go ahead and calculate the result of this. And again, I hope this comes across real nice on the webinar. Okay, it was real quick, real easy for it to calculate there. Once it has it calculated, you can use your time bar to go back and see what happened. Okay, so they roll in there. You can see the big ones sliding all the way to the end. Okay, everything's falling through as it should be. And you can hit play again. You can see they even fall to the corner because there is an angle on the study. So that's basic motion. We're not looking at other things like angular velocity. We're not plotting out all sorts of, the force that it takes to move something, those kind of things. But we do need to take into account some of the physics involved in the geometry itself. So that's where basic motion comes into play. Our third option in the motion manager is motion analysis, and that one does require SolidWorks motion to be able to work. Now when you get into motion analysis, this is where you can accurately simulate and analyze things like forces, springs, dampers, friction with material properties. There are solvers, kinematic solvers that can solve for the material property and how friction affects that. And as it says here, mass and inertial computations as well. Motion analysis also allows us to plot those results a little bit further and further analyze what the effect of the motion is on the individual components. That being said, the result of a motion study can also be exported to SolidWorks simulation to look at the stress results based upon the accelerations and forces created by the kinematic study. Okay, I have a very simple example here just to introduce motion analysis. So let's go ahead. Get the SolidWorks here. And we'll open up an example here, just very simple, again from a previous what's new. Now when you're dealing with motion analysis using simulation or motion simulation, some things kind of happen behind the scenes. First of all, I'm going to create a new motion study in this case. When I create a new motion study, what the software physically is going to do is it's going to look at all the mates within the system and convert them into motion mates. Okay, if I look at any of these mates here, you'll see I now have an analysis option as part of those mates. It converts them into a useful tool for SolidWorks Motion. From these mates, we can use these mates to drive geometry other than using a motor. We can use it to look at results at a particular joint where they're connected together. So mates play a little bit different role as we go into motion analysis. Now I still am required to select motion analysis as my type, and I have available to me all those options that you saw before. In this case, I'm going to go ahead and apply very similar conditions that we had before. This case, we're going to do a rotary motor. Change my direction here. With the rotary motor, I can now define the type of motion. In this case, we are going to stick with constant speed, and we're just going to keep it at 10 RPMs. Now, I need to help the system figure out when it's going to stop the motion. Otherwise, this thing's going to try to rotate 360 degrees over and over and over again, whether the mates will allow it or not. By doing that, we're going to use contact. I'm going to contact between two components, which we call contact groups. And I'm going to put one component in each group. Okay. Now, in those contacts, here's where we can define what the material's like. Maybe we got, they're both made out of steel in this case, which will automatically calculate some of the friction coefficient values. Okay. For us. Now at this point we still need to calculate it, so let's go ahead and calculate the model. No, you can see that it actually ran all the way through the model. It kind of blew up there in the end. Let me roll this back here. There actually is a set of options for each of these different types that we can select in here. In this case, we're using motion analysis, where we can tell it to use precise contact. It was unable to figure out the contact between those two components. So let's see if this helps us here. Okay, so now we're able to get that to rotate until that sensor hits that face and it stops properly for us. Now, from here, we're able to analyze, as I said in my description, some of the results. So I'm select maybe this face and let's plot some results. We can select a category. Is it displacement, velocity, acceleration, forces, momentum, energy, power, or other quantities? Let's do displacement, velocity, or acceleration. And let's plot out the angular velocity, the magnitude, which is the maximum. And then for positioning it, we will use the face, which will extract the coordinate system of that particular model. Okay, and it will plot out those results. Let me do that one more time because I had two faces selected there. So let's see. Displacement, angular velocity, magnitude. I want it for this face using this component's axes. Okay, and we can get a nice plot of the angular velocity of that component based upon the coordinate system of that component as well. Okay, so that's kind of what you get with motion analysis. You get to go that step further and be able to analyze what those results do, what effect those results have. Okay, so let's get into what we're trying to talk about here today. I know we're moving along here. How do I decide which one to use? First of all, animation by itself is just anything that doesn't require mass or gravity. It's more image creation, pretty picture type. That's where you get into animation. Basic motion is when you definitely need physics. You need collisions, you have parts that interact with each other in some way, but you're not worried about the result of the physics or a result of the motion. And again, motion analysis gets into more of the advanced physics, looking at those impact results and understanding the response and the forces involved. So that's generally the three things that you look at when trying to decide. Now on to the particular things that we are trying to focus on in this seminar. I felt we had to go through the others just to understand. Time-based versus event-based motion. All motion studies can be time-based or event-based. Now, that being said, there are certain modules that have to be used in order to be an event-based study, and I'll show you that. But time-based studies describe the response based completely on time. What that requires you to do, it requires you as the user to understand ahead of time how the parts interact. You need to specify the frames in which things are going to change, when a motor actually kicks off, at what point in time. You need to know when actions end so you can start new actions. You need to know what point in time that happens. Now, the problem with time-based motion is we don't always understand what time something should trigger off, like a motor or a sensor. We don't understand that. So time-based motion is somewhat limited. I'm going to show you an example, the same example in both time-based and event-based, to see the differences in what we can look at. Again, just to reiterate, time-based, you must know at what point in time to trigger off the options. So let's go and open a time-based example. You've seen this from the What's News as well. We have two blue blocks in a feeder that need to get pushed around the system and exited out the other end based upon some motors that are defined. So I'm going to go ahead and create a new motion study in this case. Now, because I'm dealing with a little bit more than just basic motion, I want to look at some of the results, accelerations. I want to look at some of the forces involved. So we're going to use motion analysis in this case. Now, in motion analysis, we need to define the motors that are going to drive all this, and we need to define the contacts between all of these as well. So let's start off defining the motors. I first need a linear motor. I'm going to use this first actuator. I'll pick the edge, and then that gives me the direction, okay, of the motor itself. Now, if I go down a little further, the motion, I have options to define what that motion is. If I just give it the speed, I won't know how long it takes to push that block down to the other end. If I go 10 meters per second, I'd have to calculate the distance and figure out how long to wait in between events. In this case, I'm going to specify a distance. And we're going to tell it as to displace 200 millimeters. We tell it when it needs to start moving to 200 millimeters and the total duration of the movement. In this case, 2 seconds to move from 0 to 200 millimeters. Okay. Now, we need to define a motor for the second actuator. So we'll go ahead and apply a linear motor there as well. I want to place it on here and pick an edge for direction. And again, we're going to pick distance as my option. 200 millimeters. Now I want it to start at this time at 2 seconds. Again, I need to know that because I'm dealing with time-based. I need to know that the first one's going to finish, and the total duration in this case is going to be also in 2 seconds. So you kind of see what I'm doing here. I'll do the same for the third and for the fourth as well. The other thing two things I need to deal with. First of all, what brings those blocks down into the system is gravity. So I needed to define gravity in the proper direction. Put it in Y, so that way when the first block gets pushed out, if you look, see there's a blue block under there. If the first block gets pushed out, I need the second block to fall into place once this is retracted. I also need to define contact. Without contact, the components that are slide can slide right through something. So we need to define contact in this case, so we'll go ahead and create a contact set. And we're going to create between multiple bodies here. I'm just going to start selecting all the actuators. There's the 4 actuators. I want to make sure I pick the 2 blocks. And then I need all the pieces that they slide on or next to. All the faces of this box, all the way around, the feeder that it ends up in, and since the block is coming down the center of this tube, I also need to select that tube as a contact as well. Okay, and it found 78 contact pairs for me. Now here's a little word of caution. These are smaller assemblies. It's a lot easier for me to pick everything and let the software determine the contact. However, the larger the assembly, the more contacts you have, the longer it will take to calculate the results. Okay, so a little disclaimer here. So let's take a look. This one's already been calculated. Here's an example of the time-based motion. Every 4 actuators all set off 2 seconds from each other. We have different contact and gravity involved here. So it pushes the first block at 2 seconds. Notice the sliding of the block if this comes across in the GoToWebinar. The sliding of the block also puts me in a little predicament here because the block actually gets to its position before the end of 2 seconds. So I can actually kick off these actuators a little bit earlier in the process. Now, I want to take a little step back here for a moment and talk in the feature manager about something called sensors. Sensors are used to sense different quantifiable values within SolidWorks. Now, if I go to add a sensor, let me just take you in here just so you can get a sense of what's available. And it's taking a second. And as you can see, I just let SolidWorks go bye-bye for a moment. Okay, let's just take a look here. It'll take me just a moment to get back up here. We're on the time-based motion. Almost there. Okay. Now back to that. I just wanted to show you an existing sensor. If I go to edit a sensor in this case, we have sensors for different types of items. One could be to look at simulation data like SolidWorks simulation. We can monitor mass properties, dimensions, interference, measurements between components, and proximity, which is the proximity between 2 components. In this particular case, they have a bunch of sensors just to notify somebody when that block is available to push the actuator. In other words, interference is detected between the block and the plate here so that it knows there's a block in position to push it. And it lets you know when the block has made it all the way around so that the actuator 3 can be completed. And then it also has one in here to tell us whether all the blocks or out of the tube. These are all just done adding a sensor between multiple components, and we're going to actually add some for the event-based, but I wanted to show you a little bit of that. Now, where we start to get limited with time-based is when we want to then retract those actuators. We would have to create either a second motor to do that, to kick off the motor, because we can't do a negative value on the motor. Once it's displaced that value, we can't go ahead and change that. If I wanted to make 2 cycles of this block, in other words, drop the first one, bring it all the way around, drop the second one, bring it all the way around, there's a couple things that I'm able to do. I'm just going to edit one of my actuators in this example, and for the motion, I now use an expression. This is something that was added in 2010, which is the function builder. The function builder allows me to specify the time steps and retractions, and allows it to do multiple time steps and retractions. There's a bunch of mathematical functions that can be applied to dictate what that motion looks like. In this particular case, it tells you the time to start. It goes from goes to 200 millimeters, then it retracts at 4 seconds to 200. At 6, it goes back to 200, and then retracts again at the end. So you can build these functions in to get a little bit further along with time-based animation. Just to show you what this looks like, here's a block getting pushed around, and you can see the last actuator. Notice you have multiple things happening at the same time because of the functions that you have, and you can see all the blocks are moved through the system. So that's what time-based animation looks like. We need to know quite a bit about time in order to actually use it. Let's talk a little bit about event-based motion. Event-based motion are defined based upon triggering events, not on time. An example that they use here, a manufacturing process includes components moving along a conveyor belt. The motors turn on or off based upon the position along the belt. As I said before, you have to know the time in which something is supposed to happen before you can trigger the motion. So that's where event-based motion will come into play. Now, using event-based motion, you can specify combination of sensors, times, when this event ends, start this event. So you can use a little bit of everything in here. Event-based motion requires tasks to be generated. The tasks can be sequential or overlap. So in that previous example, I could have all 4 actuators work at the same time, or I could have one end start versus the other. Now, a task trigger is the event that drives the motion. Okay, so let's take a look at how, and this is my last example here for the webinar, let's take a look at how we might get to event-based motion. This is a pretty neat example. We have a series of blocks that are going to fall using gravity in through this tube. Now, once they hit the bottom of the tube, we need to be able to sense that, and at that point we're going to actuate this actuator on the other side to push the block out. Now, once it pushes the block out, we need to be able to sense whether it's a red block or whether it's a block with the hole in the center. If it's a red block, it's going to be pushed off to the left-hand side into this tray that I have highlighted here. If it's a yellow block, it's going to be pushed off to the side into the other tray using the other actuator. Okay, so there's quite a bit involved here. So first thing I want to do is I want to start to define my sensors, because I need to sense whether or not I have a yellow block or a red block in place. So we're going to do that right inside of SolidWorks. So I'm going to delete the two that are here. So we'll right click and add a sensor. The sensor that I'm going to use in this case is a proximity sensor. Now we need to specify the location of the proximity sensor. Now I'm using these two cylindrical extrudes as sensors. They're there as just dummy models to be treated as a sensor. I'm going to place the sensor at the end of one of those cylinders, which places it at the very center axis. And we tell it the components to track or monitor. In this case, I want this sensor to find out if we have red blocks. So I'm going to select the two red blocks, and when they come within 12 millimeters of the sensor, I need it to tell me or alert me that the value is true. Kind of like a 0 or 1. It gives me a 1 value. Now for the other sensor, we need to do the same thing. We're going to create a proximity sensor. We're going to use the other top of the cylinder. We're going to check for components that are yellow, in this case, the two with the hole in the center. And we're also going to check for that 12 millimeter selection. Okay. Now let's go ahead and create our study. We'll create a new motion study. I'm going to use motion analysis in this case. The next thing I need to do is I need to define my motors. I have 3 actuators that are actually going to work in this case. We'll define those in the motion analysis package. So we'll select our motor. We'll say it's a linear motor, and I'm going to select the very end of the cylinder. Now that will give me my direction and everything. Now, I don't really know when this thing's going to kick off. I don't really know much about it, so I can't really specify the distance in this case or any of that. So we're going to go ahead and just specify this as a servo motor. That's going to allow me to turn it on and turn it off later. Now, what we're controlling with this servo motor is the displacement. And we're going to do that for all of these servo motors. So my motor on this side is going to be a linear motor. Select servo motor that we're controlling the displacement. And we'll do the same for the third cylinder as well. Linear motor, select the face, select servo motor, and say OK. So now I have my 3 motors in place. I have my my block sensors available. I next need to create the contacts between all the components. Now, you saw me just creating contacts before in one big bundle. Now, that's not always the best approach to this. You want to start to break down what's going to actually be coming in contact. In this case, the first thing I want to focus on is the fact that these blocks are going to be pulled by gravity into that chute. So I know these blocks are going to come in contact with that chute. So let's go ahead and create a contact. Now we're going to use contact groups. What contact groups does is any contact between components is ignored, but it creates the contact between the 2 separate items within the group. So I'm going to go ahead and select the 4 blocks. My contact on the other side is going to be the holder for those blocks, and it's also going to be the pin of the cylinder that's also going to come in contact with those blocks. So that's my first set of contact. Let me go back here for a moment. I want to show you one other thing in here. As a reminder, there is material specified in here. So I can tell it that the other material is more of a steel, a dry material, and it will change our friction values based upon that as well. Now we need to create a few other contacts here. I need to make sure that the blocks themselves come in contact with each other. So we're going to use all one group. So that way, as these things are falling down using gravity, that they aren't going through each other. We need to create a contact because once the blocks are pushed out using the actuator, I need to make sure the red blocks stay in bay 1. So we're going to use a contact group between bay 1 and the 2 red blocks because I want those to touch. And again, I'm changing my material. And then my last contact is going to be between the yellow blocks and the bay that they will sit in. So we have, in this case, this bay and the 2 yellow blocks. Okay. We need to add gravity. So let's go ahead and apply gravity in the negative y. We can also control, as part of the motion study options, the number of frames per second and the accuracy of the contact, as I said before, using precise contact. Make sure we gather everything up. Now, we need to set up the events now that actually trigger when things happen. Now, using motion analysis, off to the right, you're going to have an icon for event-based motion view. As we stated, you have to create tasks for event-based motion. So our first task, if I select the add option, we're going to call this sense solid block. So what's going to trigger the first task to go off? We can do it based upon time. We can do it based upon other tasks that we've already created, which in this case we've done nothing, or based upon our proc switches. So our first proximity switch will go off and give us a true when the red block actually gets in front of it. So when the red block gets in front of that proc switch and the alert condition is on, I want a 0.1 second delay. And then what am I going to do? What is my action for this? I want to go ahead and then turn on the motor, which is motor 1. My action is to change it. This is going to be a 75 millimeter change because we're controlling the displacement, remember. We tell it the duration that it's going to move that value and what that profile looks like for that movement. We're going to use cycloidal. Okay. Now we need to start building these tasks on top of each other. So we need a second task, which is retracting that cylinder. Okay. Retracting my cylinder. Now what triggers that? Well, we already have a previous task. So when the sense solid block task is complete, okay, so when the first one is done, do I want to delay? In this case, no. What do I want to do? I want to take the same motor, linear motor 1, I want to change it and give it a minus 75 millimeter and give it a duration to do that. We'll say 0.2 seconds, much smaller time to retract. Okay, so you kind of get an idea of what we're dealing with here. You're building one on top of the other. You're pushing these out. The next thing we would have to do is then bring out this other cylinder. So we'll use push block into tray. Okay, only when the task 1 is complete. Okay, after it's pushed the block out, we're going to give it a 0.1 second delay, and we're going to tell it to kick off linear motor 2, which is the one used to push the block off. Tell it to change the value. I think in this case it's 50 millimeters, and it's going to do it in a half second using cycloidal. So you can kind of get a sense here, and I'm not going to go through the whole setup of this particular problem, what we're dealing with. We're using sensors and events to set up the actions. Now here's what the entire device looked like from event-based. So we push the box, we retract the actuator, we push it into the bay. We retract the actuator. We push a hollow box, that hollow box only gets pushed when the prox sensors get tricked off properly. I'm going to make sure I pick my sensors here. Okay, so only when the proximity sensors go off will those go off. Now to give you an idea of what this thing looks like, let's go bring it to the beginning here, and I'll go ahead and hit play and zoom in a little bit for you. The block gets pushed out. Notice the blocks can even angle in the tube. Here comes the cylinder. It's going to drop it in because of gravity. Everything's going to kind of take over from there. But the realism of is, notice this block went right by the first cylinder, just kind of sliding there. Now we knew to actuate the other cylinder by a longer distance because it recognized there was a yellow block versus a red block. I'll let this complete here. So I hope this gives you a sense of what the difference is between time-based and event-based motion. I'll let this last block kick down here for you. I want to show you just at closing. I want to show you just a few other examples of event-based motion to give you an idea. We can also control other things in event-based motion. I'm going to show you one that's a little more complex here. I'll let this close out. Let's see. This particular one is an entire feeder station. You can see you have multiple stations. This one's a little different in that we actually have mates that we got to turn on and turn off. Components that are mated to one slide in position actually need to be able to move and get remated to something else. So I want you to just look through these tasks here. You'll notice that one of the action features is the ability to turn off or turn on mates. Notice several of these are turning off or turning on concentric mates, but the rest of this is just actuating the rest of the geometry as what we set up. This obviously takes a little bit of time to set up. There's a lot here, but look at the types of motion that you're able to get out of this. Okay, this is a pretty complex gadget that's working live in front of you. Now, while this is running, I just want to talk about some of the future and some of the other products that are out there. You can actually see how these types of motions can start to get you involved with your controls groups a lot further. There are actually products that are developed today to work inside of SolidWorks and inside of the motion analysis tool to tie into your controls groups. I'm just going to pull up a PowerPoint that I have here just so I can accurately show you what those are. This is a so the two products that you have are from National Instruments. They have a product, obviously LabVIEW, and a product called Soft Motion. which actually ties to SolidWorks, so you can use your LabVIEW and soft motion to physically drive what you just saw me doing. So you can actually get a little bit closer to the controls end of things. And then the other product that's out there is from Rockwell. Rockwell Automation has a motion analyzer, which again has an integration with SolidWorks to take a look at your motion and the quality of that motion, force results for motor selection and so on. Just wanted to make you aware of that. We are just about out of time for today. We'll go ahead and close up with our webinar for this week. Next month we will have 2 more webinars. I believe we're going to have assembly layouts and I think design tables, a real in-depth design table webinar. In case, and if there's not any questions, go ahead and we'll end the webinar for today, and I want to thank everyone for coming.